Alright guys, I'm going to go through a Gay-Lussac's law problem. Again, this is one of the examples that was already on your PowerPoint, so you should have already done this. I'm just going to go through it step by step with you. Alright, so Gay-Lussac's, this is the relationship between pressure and temperature. So our equation that we're going to be using for this is the pressure of the first gas. The temperature of the second is going to be the same as the pressure of the second times the temperature of the first one, okay? So again, as always, starting out with what we're given in the problem. Some things that we're given. The pressure of the first gas is 2.0 atmospheres. The temperature of the first gas is 18 degrees Celsius. So remember, whenever we're working with gas laws, it always has to be in Kelvin. So how we convert from degrees of Celsius to degrees of Kelvin, all you have to do is add 273. So 18 degrees plus 273 gives us 291 Kelvin, okay? So what we're solving for is the pressure of the second gas. So P2, that is going to be our unknown. The other factor that we're given in the problem is the temperature of the second gas. So again, this was 62 degrees Celsius. Again, if it's in Celsius, we have to convert it to Kelvin because all gas laws are referring to temperature in Kelvin. So again, only thing you have to do to convert it to Kelvin is to add 273, and that is going to give us 335 Kelvin for our second temperature, okay? Sorry, 335. All right. So again, all we're doing is plugging all of these numbers into this equation. So this is going to be 2.0 atmospheres times 335 Kelvin is going to be the same as the pressure of the second gas times the first temperature, which is 291 degrees Kelvin. All right, so if you multiply all of this out, this would be 670 equals the second pressure times 291 Kelvin. Again, to get the second pressure by itself, you have to divide both sides by 291 degrees Kelvin. And this, when you solve it out, P2 should equal 2.3024. And our units would be atmospheres. So now we have to convert the final answer to the correct amount of sig figs. So back to our original problem, this number has 2 sig figs, this number has 2 sig figs, and this number has 2 sig figs. So we need to convert this number down to 2 sig figs. So our final answer, the pressure of the second gas, would be 2.3 atmospheres.